Hi, Open XML developers. This is Eric White. This screencast is going to be a deep dive into some interesting aspects of word processing ML numbering and into the list item retriever module that is in PowerTools for Open XML. I'm going to walk through quite a bit of the code in list item retriever. I'm recording this screencast in April 2014, and I just completed a complete rewrite of ListItemRetriever. And I needed to do this because I discovered a few places where the previous version of ListItemRetriever didn't retrieve the right list items. I received some interesting sample documents from a developer that is using Open XML, and these sample documents had some cases where ListItemRetriever wasn't returning the right thing, so I dug into ListItemRetriever. I found out some new things about numbering in Open XML, and the first thing I did is I attempted to patch the previous version of ListItemRetriever, and I got into that a little bit and realized that I needed to do a rewrite. So I rewrote it one time, and then after that I had more clarity on how I should structure the module, so I rewrote it again. ListItemRetriever is a key component of the HTML converter module that is in PowerTools for Open XML. We have to take the list item numbering markup and convert that accurately into list item text so that we can render that text in HTML that is formatted with CSS. It's very important to that process. Over time, I expect that we will have ports of this code to Java, to JavaScript, and to C++. The information in this video will be valuable to those developers doing the ports, and that could be either other developers or it could be me some years in the future. I want to record all of this information about word processing ML numbering before I forget it all. First of all, this screencast is not going to be an introduction into word processing ML numbering. If you want a basic introduction into numbering, go take a look at the screencast at this link. That screencast gives you a basic introduction to numbering, and it also discusses the previous version of ListItemRetriever. The information on how numbering works, that's still valid, but this screencast and the detailed information that I'm going to present in this screencast takes the place of the last quarter of that screencast where I discuss ListItemRetriever. So the question is, why did I rewrite the code at this point? The first reason is that there is one aspect of numbering that became clear to me, which is, as you know, if you've seen the other screencast on OpenXML word processing ML numbering, numbering can be set directly on the paragraph, or numbering can be set through the style. But a new thing that I've learned is that numbering can also be set on both the paragraph and the style. Now, as usual, the numbering that is set on the paragraph overrides the numbering that is set on the style. So if the paragraph indicates that a particular paragraph is part of a particular numbered list, that is the relevant information, and it doesn't matter which list that the style says that that paragraph is part of. However, the formatting that is in that style and the formatting referred to by that list item in the style is still relevant. It just gets rolled up along with all other paragraph and run properties that we need in order to format that list item. Let's take a real quick look at this, at the actual markup that caused me to decide that I needed to restructure the code almost completely. Let's take a look at some markup. Let's create a document and add a couple of lists to the document. I'll add a few items here. I'm going to format this. First of all, I'm going to switch this to print layout. And then I'm going to format this as heading 1, and I'm going to format this as heading 2, and another heading 1, and another heading 2. Now I'm going to come up here and I'm going to change the formatting so that it uses Article 1, Section 1.01 and Article 2, Section 2.01. This is a variety of numbering that uses the style to configure the numbering, and we'll take a look at that in just a minute. And I'm going to add another list down here, and I'll add this list as a straight numbered list, something like that. Then in order to make my experiment doable, I'm going to add one more paragraph. And I'm going to make that heading 1. So now let's save this and let's take a look at this document in the Open XML package editor power tool for Visual Studio 2010. First thing that we'll do is we'll look at the numbering on these styles. So here we can see that we have a paragraph styled as heading 1. Now if we go to the styles part, down here we can see the numpr element that indicates this is part of a list with numID of 1. One thing about this is because this doesn't have an ILVL, then it means it has the default value of ILVL is equal to 0. And that means it's the list item that is indented as far as possible to the left. If we drop down and look at heading 2, we can see here that the ILVL value is set to 1, and that means it's the next level of indentation below the ILVL of 0. Now let's go back into our document and we can drop down near the bottom of the document, and down here we can see those numbered items where we actually set the numbering directly on the paragraphs. Here we can see we have a paragraph and the paragraph properties are underneath the paragraph, and in the paragraph properties there's a numpr element that has a numID of 2, and here we have an ILVL of 0. All of the items in this list have an ILVL of 0. All that's all fine and good. We have two separate lists. One is formatted by styles, the other is formatted by a numpr set on the paragraph properties. Now let's do something a little bit interesting. Let's come down to the last paragraph that is styled as heading 1. So that means they're part of the styles version of numbering. And let's put the numpr element directly into the paragraph properties for that paragraph. So this paragraph now has two sets of numbering. One is directly on the paragraph and the other is part of the style. Let's save it and open it in Word. And we see a couple of things here. One thing is we can see down here that this paragraph that is styled as heading 1 is now part of the list that is styled as 1, 2, 3, and 4, as opposed to the paragraph that is styled as Article 1, Section 1.01. But interestingly enough, we can do something else. Let me close this document. We can change some properties on the numbering that is set via the heading 1 style, and those will flow through. And you'll see then that properties are effective both in the numbering that is referred to by the heading 1 style, and properties have effect that are stored in the numbering that is referred to by the numpr in the paragraph itself. To review real quickly, the numbered list that is styled on the paragraph has a numID of 2, and the numbering that is numbered via the styles has a numID of 1. Let's go to the numbering part and go to the end. So the ones set on the paragraph have an AbstractNumbID of 0, and the ones set via the style have an AbstractNumbID of 1. So let's first of all go to the AbstractNumbID of 0. This is the numbering that is set via the paragraph. And I'm going to get rid of the paragraph properties here that set the indentation. And further, I am now going to go down to the numbering that is set via the style. So this is AbstractNumbID of 1, and I'm going to change the left property on the indentation to 1000. Let's save that, and let's open the document and look at it. Well, sure enough, we can see that up here, Article 1, this is indented to 1000. And what we see down here is this last paragraph here. It certainly is part of this second list that has 1, 2, and 3 in it. It gets the number of 4, and it also inherits the indentation property of the numbering that is set via the style. So this is a long way of saying that in the new version of ListItemRetriever, as it accumulates the information about items in a numbered list, it retrieves the information both about numbering properties that are set via the style and numbering properties that are set via the paragraph, because both of those can be effective simultaneously for a given paragraph. That was the first reason that I needed to do a major change here. The second reason I needed to do a restructuring of the code is the use of numID is a little bit more complex than I previously understood. As you probably know, the numpr element points to the numID in the numbering part. The num element in the numbering part contains the AbstractNumbID, which determines which list a paragraph is part of. However, there is a StartOverRight element that can be in the num element, not the AbstractNum element, and the rules on how this StartOverRight element take effect are interesting. So let's take a look at that. First thing let's do, I've created a document here called restart01.docx. Let's take a look at some markup in here. Here in this document, I have a number of paragraphs that are styled with either a numID of 1 or a numID of 2. If we go into the numbering part and go to the end, we'll see here that both the numID of 1 and the numID of 2 down here refer to AbstractNumbID of 0. This means that anything that is styled with a numID of 1 or a numID of 2 are part of the same list. But the difference here is those items that are numbered with a numID of 2 take on these level overrides down here. for a level override of ILVL equal to 0, the start override is equal to 12. For an LVL override with an ILVL of 1, the start override is 5. Let's look at this document. In this document, I've made the contents of the paragraph reflect which NumID I'm using. I just put in that content directly. So here we can see this is all part of NumID of 1. And then we get down here and we see a NumID of 2. And as expected, we see that the start override for the ILVL of 1 is 5. So far, so good. Let's look at the first little interesting complication associated with this. I'm going to change this item right here to have a NumID of 2. So here's the NumID of 1, 0, 1, 1, 1, 1, 1, 1. The next 1, 0, 1, 1, 1, 1. Here's that 2, 1. The second 2, 1. Here's the third 1, 0. And down here, I'm going to change this second item to have a NumID of 2. And let's change the contents of this paragraph so it reflects what I'm trying to show you, so that we can see the contents of the paragraph will tell us what the NumID is for that particular paragraph. And here we can see our second NumID of 2. We see up here the restart is in effect, and we see 5, 6, and 7 for those items. When we get down here for this NumID of 2, the restart is not in effect. So when you start using a particular num, the start override is only relevant in that document the first time you use it, except for one other case. And that is that if I set this paragraph here to be NumID of 2, it doesn't take effect for this paragraph because that NumID of 2 has already been used right up here, but it takes effect for its children paragraphs. Let me show you what I mean by that. What I'm going to do is I'm going to change this paragraph here so it uses NumID of 2 and it's at an ILVL of 0. Let's go look at the document now. And here you can see where I've set NumID of 2 and an ILVL of 0. And sure enough, you can see its children elements now take on the start override of 5, 6, 7, and 8. So that's the first set of two interesting rules. The first interesting rule is the NumIDs are effective for a paragraph only the first time that it's seen in a document with regards to the start override. And the second interesting rule is that the exception to the first rule is that if you use a NumID on a paragraph, the start overrides are effective for its children paragraphs. So now I'm going to go up here and I'm going to change these to go back and use NumID of 1. So therefore this 2, 0 will be the first use of the NumID of 2. And what we're going to see is instead of starting numbering at 3, it's going to start numbering at 12 because that's what the start override is set for NumID of 2. So here are those two. I'm going to change this to 1. And let's change the text of the paragraph to match. And again, this is 1. And I'm going to change the text of the paragraph to match. So now let's open up the document. And sure enough, Now this third paragraph at level 0 starts numbering at 12. So the level override with the start override of 12 is in effect for this paragraph because it's the first time that NumID has been seen in the document. And of course, it's also effective for its children because that's the other rule that's in effect, is that a NumID set for a particular level of a paragraph is in effect for all of its children, regardless of whether that particular NumID has been seen in the document before or not. So these were the two things that I ran into that caused me to rethink the whole list item retriever. The first is that I had to keep around information about numbering that is set on the style and information about numbering that is set on the paragraph. And second of all, I needed to implement this interesting set of rules for start overrides, which I've detailed. Now we're going to walk through a lot of the code that is in ListItemRetriever, and I'm going to go through this pretty quickly. In a way, this is not a tutorial at all into ListItemRetriever. This is only for people who need to understand exactly how ListItemRetriever works. When you call retrieve list item for a particular paragraph, the first thing this method does is it looks for an annotation of type ListItemInfo on the X element that contains the paragraph. If that annotation is equal to null, then it calls this method initializeListItemRetriever. After this method initializeListItemRetriever returns, every paragraph in the document is going to have an annotation of ListItemInfo. However, some of those paragraphs, if they're not part of a list, the only thing that's in effect is a Boolean that says it's not part of a list. So let's go look at this ListItemInfo class for 1 minute. As I said, the first thing that there is in there is a Boolean that says whether it's a list item or not. The second thing is that it's got these two list item sources. One is from the style and the other is from the paragraph. So it collects the data about any list that this particular paragraph is part of and keeps it here in this ListItemInfo object. If we look at the ListItemSource here, we see something called the ListItemSource set. And that's because if a list item is part of a style, it can actually have in effect two abstract NumIDs if the NumStyle link name is set. If you want to see an explanation of how NumStyle link is used, take a look at the MSDN article that explains numbering in detail. You can get it at this bit.ly link. And then if we go look at a list item source set, we see it has the NumID in there. That's an interesting piece of information for us. It has the num element from the numbering part, and that's going to have all of the level overrides that are set for that particular num element. It's going to have an abstract NumID, and that's the abstract NumID that is pointed to by the num element. And it's going to also have the abstract num element, and that contains the XML for the abstract num. If you look at these classes, there are various properties. So for instance, there is an abstract NumID property. It does a little bit of local caching here, which is it gets the abstract NumID for that paragraph, and it sets it in a private member, and then it returns it from that private member if we've retrieved it previously. It's just a little bit of optimization. That's all that is about. So we don't have to go through and dig through all the information to figure out what the abstract NumID is multiple times. We only want to do that work once. That's what these two lines of code are about right here. And next thing is it sees if from paragraph is not equal to null, and then it returns the AbstractNumID from the paragraph, because the paragraph overrides the style with regards to the AbstractNumID. And then if from style is not equal to null, it gets the AbstractNumID from the style. And finally, if it doesn't have either of those set, it returns AbstractNumID, and that's going to be null. There are a number of properties here in these classes that implement the right rules about this AbstractNumID overrides that AbstractNumID, or when we're getting the ILVL, we're going to get the LVL element from one particular place versus another particular place. We don't have to go through all of that code in detail. I'm pretty sure it's all accurate. Let's now go look at the code in InitializeListItemRetriever and see what it does. When I go to that method, it iterates through all the content parts in the document and calls InitializeListItemRetriever for that part. I have a little bit of code right below that iterates through all the content parts and just validates that every single paragraph in the document then has a ListItemInfo. After we get done with InitializeListItemRetriever, all paragraphs in the document will have a ListItemInfo annotation on them. Let's go to InitializeListItemRetriever for part. It does a bit of work to get the X documents for the numbering part and the styles part. And then it initializes the ListItemRetriever for a story. And in a nutshell, a main document part can have multiple stories because text boxes are their own stories. And the way that list items work is they interact only with paragraphs that are in their own story. So therefore, in the method InitializeListItemRetriever for story, it uses the trimmed versions of the descendants method, which means that when we get to the txbx content element, we don't look for any descendants below that. And then up here, we iterate through all of the text boxes and initialize the ListItemRetriever for those stories. And if you can have a text box inside of a text box, which is certainly possible, this will also work. It will initialize all of those stories for those nested text boxes. And then for every paragraph in a particular story, it calls init_ListItemInfo. In init_ListItemInfo, there are a couple of interesting aspects. One interesting aspect, for instance, even if you have a paragraph that indicates it's part of a list, but that paragraph is empty except for a section break, then that paragraph is not part of a list. It doesn't get counted when we're counting items in a list. If you have some list and then you stop halfway down through the list and then you insert a section break, you don't want that paragraph that's in the middle of that list to be counted. You don't want a number on the section break itself. You just want to have the section break, and then further down numbering will continue as usual. The next interesting piece of information is for a particular paragraph style name and a paragraph NumID, there will be one particular list item info. If the numbering comes from the paragraph style, then the paragraph style name will cause that numbering to be pulled in properly. If the numbering comes from the paragraph, then the paragraph NumID will cause that numbering information to be pulled in. And if both are set, we need to get both of them. So therefore, there's a little optimization here where it gets the list item info from a cache. This is just an optimization to save us from doing as much work as possible. We want to make this execute very quickly, particularly for really, really large documents. If this list item retriever module is not implemented properly, it can suck up a lot of CPU time in a really large document, and we don't want that. And it doesn't. It does appropriate intelligent caching, so it doesn't do that. If it gets it from the cache, then it adds it as an annotation to that paragraph, and it figures out the ILVL for that paragraph, and then sets the paragraph level for that paragraph. One thing that you'll notice is that it calls this method setParagraphLevel. Let me go into that, and that sets another annotation on the paragraph of this type, ParagraphInfo. And ParagraphInfo, at this point in time, all it has is an integer with the ILVL. And that's because it's a fair amount of work to figure out the ILVL for a paragraph, so we only want to figure it out once. So we use an annotation on the paragraph to cache the ILVL for a particular paragraph. And down here, if the from paragraph is set to null, but the from style is not set to null, then we have to figure out the ILVL from the styling information, not from the paragraph information. And then we set the paragraph level. If we don't find that particular list item info in the cache, then we have to put it together. We new up a new list item info, and if the paragraph style name is not equal to null, then it sets from style to the results of this method initialize style ListItemSource. And if the paragraph numbering properties are not null and there is a NumID, then it sets the from paragraph field to the results of initialize paragraph ListItemSource. There is another rule, which is that if the NumID is set to 0, then that means it's not part of a list. It can have a numpr element, but if NumID is set to 0, then per the standard, it's not part of a list. These methods, initialize style ListItemSource and initialize paragraph ListItemSource, return a Boolean that indicates whether the NumID is equal to 0 for either one of those. And then down here, if the style 0 NumID is set to true and there isn't a paragraph 0 NumID, or if the paragraph 0 NumID is set to true, then we say this is not a list item and return. There are a few other rules. If the multi-level type is set to single level, then it doesn't matter what ILVL is set to in either the paragraph or the style. The ILVL needs to be set to 0. Once we have initialized the list item info for every paragraph in a story, then it's easy to get the list of AbstractNumIDs from all of those paragraphs. Here's just a little query to do that. That'll get the list of distinct NumIDs that are used in that story. And then it iterates through every one of those AbstractNumIDs and then gets a list of all the list items right here that have that particular AbstractNumID. And when we get done with that, this list of paragraphs right here is set to the complete set of paragraphs that are part of that numbered list. This is an interesting point right here in the code, that this list items list contains the paragraphs, the sum total of all the paragraphs that are part of that particular list. Another thing, once we have that list of list items, then we go through and annotate every paragraph with its previous paragraph. And the reason why is we have to look at previous paragraphs at various points in determining the numbering for every item in the list. And because we want good performance, then we do this annotation. I mentioned in the earlier part of the screencast that there's this issue with the StartOverRight already used. It only gets to be used once in a particular story, so we keep a list of every StartOverRight and when they are used. These are actually a list of the NumIDs when they're used, but I call it StartOverRight already used to remind me of the reason why we care whether it's already used, and that's because the StartOverRight is only in effect the first time. And then down here is a bit of fairly complex code. It starts here on line 962 and it ends down here on 1087, so 120, 130 lines of code. And this is the code that actually figures out all the numbers for every item in every list. This also takes into consideration the level restart. There is this ability in Open XML to say, for a particular level of a list, don't restart this until another level up higher is seen. So in other words, you could have level 0, then you have level 1, and that level 0 and level 1 are as usual, and then you can have a level 2 such that level 2 doesn't restart until you see a level 0 again. This is a type of numbering that people use when they want every single paragraph in a document to have their own numbering, but they also need to have other forms of numbering that indicate hierarchy or something like that. So they want every paragraph to have its own number, and that number doesn't reset even when the level up above changes. It doesn't reset until level 0 changes, for instance. Main point here is this algorithm needs to implement that, and there's a little bit of code in here to take care of that issue. I'm not going to go through all the nitty-gritty of how these 120 lines of code work. If you're a person who needs to implement this algorithm, you're going to be digging through this code in any case. I just wanted to identify these are the 120 lines of code that do the real guts of the work. After that code determines the level numbers for every single paragraph in that list, then it creates another object that we're going to use as an annotation, and this is the annotation that contains the ordinals of the level numbers for every single paragraph that's part of a numbered list. So if a paragraph is part of a numbered list, then we will find this level numbers annotation on that paragraph, and that contains the level numbers for that particular paragraph. At the end of calling initialize_ListItemRetriever, every paragraph in the document has a ListItemInfo. Every paragraph that is part of a list has an eye level for that paragraph. It has an annotation that caches the eye level for that paragraph. It also has a list of the ordinal numbers for every level of numbering for that paragraph. So what I mean that the level numbers would be something like 1.1.2 or 113 or 114 or 121, depending on where that item is in the set of numbered lists if you have a hierarchical numbered list. Now, once again, we're looking at the retrieve list item method, and this is the method that called initialize list item retriever for a document. And as I've mentioned, when we get back, every paragraph will have a ListItemInfo annotation on it. So the only work that this needs to do is get the language identifier and format the list item. It has all the information necessary to do all of that. It has the level numbers, it has the list item info that gives us all of the information about that particular list item, including if that paragraph has list item information on the style and if that paragraph has list item information on the paragraph. And then it can call format list item and get the text of the list item. And if we take a look at that method, we see all of the various work that it needs to do to get the tokens for the LVL text template, get the level numbers, convert the level numbers to the actual list item. Down here, this is where the code calls the various implementations that other contributors have put together for implementing correct list item retrieval for Russian or German or French. And if one of those culture-specific implementations return null, then we call the default implementation. And then we finally concatenate all of those strings together and return the list item. We can see the last method down here is this method to tokenize the level text. I don't need to necessarily go through all of that. It's just straightforward tokenization of a string. Well, if you're one of those developers who make it to this particular point in this deep dive, congratulations. There are probably very few people who need this information, but those who do need this information want to know it and want to know exactly what the correct information is here. And in fact, I'm going to probably need to review this screencast when it comes time to do implementations in other languages. That's all I'm going to cover in this video. That was more than enough. Take care.